Next, we'll be looking at the guided notes for 2.6, special functions. And the first special function I want to introduce you to is the piecewise defined function. Now, a piecewise defined function is a function that is written using, it's a function that is written using two or more expressions. The way it makes most sense to me is that the domain of the function is broken into pieces. Other people find it easier to think of these functions as though the function itself is broken into pieces. Whatever way you think about it, this type of function can be very useful in the real world. Let's try graphing one of these piecewise functions. First of all, I want to introduce you to these in a way that I never was. The function f of x is equal to, and here is the definition of that. The domain, remember, domain is just your x values. So this part right here, this is where my initial focus goes when I look at these things. I look here first before I do anything else. I could care less what this says. I need to know what this says first. So my x values that are less than -1, so here's -1. So every x value that's less than -1 is going to follow this rule, x minus 2. So for all the x values that are equal to or bigger than -1, so all the ones to the right of -1, they're going to follow the rule of x plus 3. Now, I know we know how to graph x minus 2. I know we know how to graph x plus 3. We just got done graphing lines. So here, I can only graph x minus 2 if I have x values that are less than -1. Alright, so the first thing I'm going to do is I'm going to establish my domain break. In other words, what is this value right here? It is a -1. I want to establish where my domain is broken. And so here at -1, I'm going to draw a better line here. So at -1, and it's a dashed line, and really, this isn't something that you have to have, and you may even get counted off for it in other places. However, for me, if you draw this dashed line, that lets me know that you're thinking in terms of the domain break, and that's very important to note. The second thing I want you to do with these, the second step is to determine which expression belongs to each piece of the graph. So here, I have basically karate chopped this thing into two pieces. This graph now has a left side and it has a right side. The left side, all the x values that are less than -1, so here at -1, all the values that are smaller than that, they're going to follow this y equals x minus 2. Notice how I use y equals instead of f of x equals, because f of x is the same thing as y. I'm going to try and say that as much as I can this year, just so we're familiar. So y equals x minus 2 is the graph that I'm going to have on the left side. On the right side, I'm going to have y equals x plus 3. Now, I want to graph. Since we're in slope-intercept form, I'm going to graph using slope-intercept form. So here, x minus 2, it crosses the y-axis at -2, but I need to be careful. That's on the right side of my domain break. I can't graph here. So what I'm going to do is I'm going to count my slope until I enter my portion of the domain. So I'm going to count my slope from -2 like I normally would. It's a +1. My slope here for this one is 1. That is 1 over 1. That's a rise over run. So I would start at -2, go up 1 over 1, but I can't. I can't go to the right. This graph only happens on the left-hand side of the domain. So I'm going to go down 1 into the left one, starting here. and then down one to the left one. And this gives me my graph. Just like so. And then I want to graph the other one here. So this is y equals x plus 3. All right, so my y-intercept is 3, so I'm going to cross here at 3. So I touch at 3. And this graph goes up 1 and over 1 because my slope m is 1, so it's up 1 over 1 as well. And I want to make sure I go all the way until I hit my domain break as well. So I start here and I go on. So let's get that line in. That way forever. Now once I've graphed, then my notes say if the graph is discontinuous at the domain break. Now I'm introducing a really big term. The only thing I mean by that is if the left side doesn't touch the right side. In other words, here I have a huge jump or a big gap between the left-hand side and the right-hand side. So since that's the case, I need to determine which is included and which is not included. And that brings my attention to these guys right here. Since this is less than, not less than or equal to, this is less than, I'm going to have an open circle for this one. And since this is greater than for x plus 3, then I'm going to have a closed circle here. I'm going to close dot right here. And it's important that we establish that. My open and closed circles. So I hope this gives you some sort of an idea on how to begin with piecewise functions. The exercises that we will do for this are going to be determined in class. So I'm not going to give you your homework from here, but from class we should have a good idea of what problems to do.